Scientists discover planets more habitable than Earth. For centuries, humanity has gazed up at the night sky and wondered if life exists on other planets. The notion that extraterrestrial civilizations may live on faraway worlds has captured our imagination through science fiction and inspired serious scientific inquiry into the possibility of life beyond Earth. Now, advances in astronomy and space exploration have brought us closer than ever before to finding potentially habitable worlds within our galaxy. Recent discoveries of Earth-like exoplanets orbiting other stars in the Milky Way have shown that our solar system is not as unique as once thought. Worlds with characteristics that could support life as we know it seem to be more common than previously believed. This raises intriguing questions about the abundance and diversity of life in the cosmos, as well as the prospect that one day we may detect signs of extraterrestrial biology or even intelligent alien civilizations. In this article, we will explore some of the most promising exoplanets found to date that possess qualities making them potentially more habitable than Earth. We will look at how scientists identify and characterize habitable zone planets, the latest discoveries pushing the boundaries of where life could exist outside our solar system, and what these findings reveal about the likelihood that life is ubiquitous throughout the galaxy and universe. As our technology improves, astronomers are finding that worlds with life-sustaining qualities appear to be more the rule than the exception. The hunt for alien life has never been more exciting, and the possibility that we are not alone in the cosmos looks more promising than ever before. What makes a planet habitable? Before looking at recently found exoplanets that could be more livable than Earth, it is important to understand what specific planetary characteristics and conditions scientists believe are necessary for habitability. Some key attributes that experts think are needed include location in circumstellar habitable zone. A planet's location in relation to its host star is critical. It needs to orbit at just the right distance to allow liquid water to exist on its surface. This orbital region is known as the circumstellar habitable zone, sometimes called the Goldilocks zone, since conditions must be just right, like the fairy tale porridge. A planet that orbits too close would be too hot for liquid water, while one too far would be permanently icy. To have habitable conditions like Earth, it needs to be in that sweet spot where surface temperatures allow for liquid water oceans. Right mass and composition. Size matters when it comes to habitability. A planet needs enough mass to maintain an atmosphere over billions of years, but if it is too massive, it risks developing a thick atmosphere of hydrogen and helium like Jupiter and Saturn, inhospitable to life as we know it. The best candidates are rocky planets around 1 to 4 times the mass of Earth. Composition affects the dynamics of the interior and geological activity like volcanism that can create an atmosphere. Iron and silicate rocks like Earth are optimal. Stable orbit of host star. The planet needs to follow a stable orbit that doesn't vary to extremes over time. Drastic changes in distance from the host star would cause wild temperature swings. If the host star has a very eccentric orbit around the galactic core, intense radiation could periodically blast the planet and any life struggling to survive. An orbit in the continuous habitable zone of the galaxy is ideal. Magnetosphere to protect atmosphere. A magnetosphere generated by a rotating iron core like Earth's offers crucial protection. It shields the planet from stellar wind and radiation that can strip away its atmosphere. Without a magnetosphere, any atmosphere containing the gases necessary for life would slowly erode into space. This magnetic cocoon is essential for habitability. Plate tectonics to maintain stable climate. Evidence suggests plate tectonics helps regulate a planet's climate by recycling material and gases through the interior. Active geology also fosters nutrient cycling necessary for life. A planet capable of plate tectonics is thought to be more likely to develop and sustain the equilibrium conditions life requires. Lack of tectonics could lead to a runaway greenhouse effect like on Venus. Right atmospheric pressure and composition. An atmosphere with pressure near or similar to Earth's allows for liquid water to exist on the surface and protects against dangerous cosmic radiation. The gases present must include water vapor, nitrogen, oxygen, carbon dioxide, and others in the right amounts. Too much CO2 and methane, like on Mars and Venus, can result in drastic heating. The atmosphere cannot be too thin or thick, another reason mass and gravity are important. With these characteristics in mind, astronomers have been searching for worlds outside our solar system, called exoplanets, which have the greatest potential for being habitable environments. New telescope technologies and detection techniques have led to groundbreaking discoveries of Earth-sized worlds in alien solar systems. The search for life has brought us closer than ever to answering that most profound question: are we alone in the universe? Methods for discovering potentially habitable exoplanets. In order to locate distant exoplanets with characteristics suitable for life, astronomers rely on two primary methods: radio velocity and transit photometry. Each offers a different way to detect these worlds light years away. Radio velocity. This technique looks for signs of a planet based on the gravitational wobble it induces on its parent star. As an orbiting planet tugs on the star, it causes a slight periodic Doppler shift in the wavelength of the star's light. By measuring these spectral variations, scientists can calculate the mass of the planet and characteristics of its orbit, even though the planet itself is too faint to view directly. Transit photometry. This method observes stars for a temporary dimming in brightness that indicates a planet has passed in front of the star. The tiny dip in light can reveal the planet's size and orbit. By combining data from the transit with radio velocity observations, astronomers can determine the mass, structure, and size of exoplanets. Advances in other techniques like direct imaging and gravitational microlensing have also aided exoplanet detection. But radio velocity and transit photometry remain the most widely used and successful methods for identifying potentially habitable worlds. They enable scientists to pick out subtle signals that expose planets with life-sustaining qualities. Notable exoplanets with Earth-like qualities. In the past decade, the catalog of known exoplanets has grown exponentially. Out of the thousands confirmed so far, a subset possesses particularly compelling characteristics that make them contenders for being more habitable than Earth itself. Here are some of the most notable. Kepler 186f. This exoplanet was the first Earth-sized planet found orbiting in the habitable zone of its host star. Kepler 186 has a radius just 10% larger than Earth's and orbits a red dwarf star about 500 light-years away in the constellation Cygnus. It circles toward the outer edge of the habitable zone, so if it has an atmosphere, it is likely thicker than Earth's to keep the planet warm enough. But scientists think it may be one of the most habitable planets found outside our solar system. Kepler 442 bits. Located about 1,100 light-years away, this exoplanet is nearly the same size as Earth and orbits in the middle of its star's habitable zone, much like Earth does around our Sun. Kepler 442 bits' orbit places it at a similar temperature to Earth as well, increasing chances that it is rocky, terrestrial, and able to hold liquid water. However, since it orbits a dimmer, cooler star than our Sun, the planet may be subject to intensive flaring activity that could erode any atmosphere. K218 bits. This planet, about 124 light-years away, is a super-Earth exoplanet, 2 times the size and 8 times the mass of our planet. K218 bits orbits in the habitable zone around a red dwarf star. What makes this planet exciting is that it has been confirmed to have water vapor, the first such discovery for an exoplanet in the habitable zone. The presence of water raises the possibility that other Earth-like qualities needed for life also exist. GG 357. A planet found orbiting a nearby red dwarf star just 31 light-years away. GE 357 is about 6 times larger than Earth. It resides at the inner edge of the star's habitable zone. Scientists calculate it may have a dense atmosphere that could allow surface water to pool despite its proximity to the star. More study is needed to determine if it is rocky and how much radiation it receives, but its location around a nearby star makes it an intriguing target for future observation. LHS 1140 bits. This recently found super-Earth 41 light-years away is just over 7 times our planet's mass and orbits in the habitable zone of a red dwarf star. LHS 1140 bits is one of the closest exoplanets identified so far with characteristics amenable to habitability. Scientists think it is likely rocky with a thick atmosphere, but there is some debate over whether the planet is tidally locked with permanent light and dark sides that could limit habitability. These are just a few of the most Earth-like exoplanets found that show incredible promise for potentially hosting life on the basis of their predicted composition, orbits, and host star types. As more data is gathered and modeling techniques improve, astronomers continue honing in on exoplanets that have realistic chances of being even more livable than our home planet. New discoveries pushing the boundaries. Not all the exoplanets most likely to harbor life reside neatly in their star's habitable zones as traditionally defined. Ongoing exploration of our stellar neighborhood has uncovered worlds that expand or challenge our notions of planetary habitats where life could thrive. Amazing new discoveries are pushing scientists to reconsider where biology could emerge and take hold. TRAPPIST-1 system. Around 40 light-years away, TRAPPIST-1 is an ultra-cool dwarf star orbited by 7 closely spaced Earth-sized exoplanets. 3 orbit in the star's habitable zone, and all could potentially have liquid water under the right atmospheric conditions. Though tidally locked with permanent day and night sides, TRAPPIST-1's dimness means even its closest planet receives similar radiation as Earth. This remarkable system with multiple possibly habitable exoplanets is completely different than our solar system, prompting new ideas about abundant planetary habitats. 55 Cancri. This super-Earth exoplanet, twice Earth's size, located 40 light-years away, orbits so close to its sun-like star that it seems inhospitable at first glance. But observations show 55 Cancri likely has an extreme molten surface and dense supercritical atmosphere with ingredients like water, oxygen, and nitrogen. Hypothetical life may exist in this dynamic atmosphere much different than Earth's. Enceladus. A moon of Saturn with a subsurface ocean hundreds of miles wide, this frozen world is an intriguing candidate for discovering life beyond Earth in our own solar system. Discovery of molecular hydrogen in Enceladus plumes indicates hydrothermal activity and chemical reactions needed to support microbial life. Its potentially habitable ocean lies far from the Sun under miles of ice, expanding conceptions of hospitable zones. Europa. Another promising moon in our solar system, Europa has an icy crust covering a vast, salty ocean more than 60 miles deep, containing twice as much water as Earth's oceans. Tidal heating from Jupiter may provide energy for life beneath Europa's frigid shell. Hydrothermal vents could supply nutrients needed for biology in this sunless abyssal zone. Exploring ocean worlds broadens targets in the search for extraterrestrial organisms. Advances are also being made in identifying potentially habitable exoplanets without surface liquid water. Some may have subsurface oceans heated geologically, still offering environments where life could originate and evolve. There may even be rogue planets ejected from solar systems that generate enough internal warmth to sustain subterranean habitats. Such discoveries are transforming assumptions about where life can get a foothold. Assessing the chances for life. With so many recently found planets possessing properties conducive to life, researchers are growing more confident that environmental conditions suitable for biology are prevalent beyond Earth. Several lines of evidence point to an abundance of potentially habitable worlds across our galaxy and the universe as a whole. Billions of Earth-sized exoplanets. Statistics from the Kepler mission indicate there are at least several billion Earth-sized exoplanets in our galaxy alone. Billions more likely exist across the universe. Even if only a tiny fraction develop habitable conditions, the number with biology could still be enormous, given the sheer quantity of planets. Most stars host planets. Surveys find the vast majority of stars in the Milky Way have planetary systems around them. Stars without accompanying worlds appear to be the exception. With hundreds of billions of stars just in the Milky Way, the number that host potentially habitable planets is likely very high. Red dwarfs are most common star type. About 75% of stars in the galaxy are red dwarfs, small, cool stars with incredible longevity. Though prone to flaring, red dwarfs like TRAPPIST-1 seem able to support multiple habitable zone planets over their long, stable lifespans measured in trillions of years. The predominance of red dwarfs signals a multitude of worlds orbiting low-mass stars. Habitable zones are larger than thought. The circumstellar habitable zones around stars were initially depicted narrowly, but growing evidence from exoplanets suggests liquid water habitats could exist over a wider range of distances and conditions. Stars can host multiple planets in extended Goldilocks zones. Life could form and survive almost anywhere. From Europa's ocean to 55 Cancri's atmosphere, discoveries show life can evolve and thrive in incredibly diverse environments. This adaptability hints that even exoplanets with harsh conditions compared to Earth could support some forms of life. Even free-floating rogue planets could harbor biology. Based on such findings, many researchers posit that life is likely plentiful across the cosmos. Conditions suitable for at least microbial life to arise and evolve seem commonplace. A number of experts think it statistically improbable that life is unique to Earth when so many other worlds exist with the prerequisites for biological genesis and survival. Of course, we still have just a partial picture of exoplanets within a very limited region of one galaxy. Debates continue over just how likely or abundant life truly is on a universal scale. But our ongoing exploration of strange new worlds brings us ever closer to answering the fundamental question of our place in the universe. Does earthly life represent a rare, precious foothold? Or is the universe brimming with living worlds populated by complex organisms, some perhaps even intelligent species attempting to communicate across interstellar gulfs? Our accelerating progress in astronomy promises to reveal just how alone we are as we gaze contemplatively at the stars. Don't forget to like and subscribe to our channel so you don't miss new videos.